Wi-Fi data transmitter. Many times, we need to transmit the data over a long range. In this case, Wi-Fi or Internet is the most suitable option. We can use this system to transmit any message or the readings of any sensor to any remote location. The only limitation of this system is the availability of Internet signal. In this video, we will learn how to send data over Wi-Fi using Arduino and ESP8266 IoT module. This is the connection diagram of this project. ESP8266 module has 8 pins. Its 4 main pins are VCC, ground, RX, and TX. Connect the VCC pin with the 3.3 volt pin of Arduino, and connect its ground pin with the ground pin of Arduino. TX pin of ESP8266 will transmit the data to the Arduino, so connect it with the RX pin of Arduino. RX pin of ESP8266 will receive the data from Arduino, so connect it with the TX pin of Arduino. This is the code of this project. Void setup is a function that we create at the top of each program. Inside the brackets is the code we want to run once. As soon as the program starts running, serial begin 115200. This line defines that data will transmit from Arduino to ESP8266 at the rate of 115200 bits per second. Delay 1000. It will stop the program here for 1 second. Serial print lane. This is the syntax of the command used to send the data from TX pin of Arduino. ATE0. This is the command of ESP8266 IoT module. It will turn off the echo. /R/n is the code of enter key. AT plus CW mode def equals 2. This command will set the IoT module in access point mode. AT plus CIP mux equals 1. This command will enable multiple TCP connections with the IoT module. When we connect any device with the IoT module, then module allots it a specific connection ID, like first device get the connection ID 0, second device get the connection ID 1, and so on. AT plus CIP server equals 1. AT. This AT command will make ESP8266 a TCP server. Void loop. This function continues to execute the code written inside it over and over unless we reset the Arduino hardware board. AT plus CIP send equals 0, 32. It will send 32 characters to the device with connection ID 0. In next line, we will write the message to be sent. Similarly, we will send another message with 28 characters. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, we will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Our code has been uploaded to the hardware successfully. Now we will assemble our hardware. This is the ESP8266 IoT module. First of all, we will take two 10 kilo ohm resistors. We will connect one end of a resistor with the RST pin, and one end of another resistor with CHPD pin of IoT module. We will connect the second terminal of both the resistors with the VCC pin of IoT module. Now we will insert the wires. In the header pins, we will connect a red wire with the VCC pin, black wire with the ground pin. Now connect the green wire with the RX pin and yellow wire with the TX pin. Now we will connect it with our Arduino hardware board. Connect the red wire with 3.3 volt pin and black wire with the ground pin of Arduino. Connect the yellow wire with the RX pin and green wire with the TX pin of Arduino. Now we will power up our project and test its functionality. We will see the transmitted data on our mobile phone. So first of all, we will turn on the Wi-Fi of our mobile phone. Wait till the mobile phone connects with the ESP8266 module. Now open the mobile telnet app. Go to the settings and type the given IP address and port number. Now press the connect button. We can see that our IoT module is transmitting the data and it is displaying on our mobile phone screen. Our circuit is working perfectly. I hope you enjoyed the video and learned something from it. For any help or to clear your doubts regarding your project, you can contact us on our student care number 7007957715. To buy the items used in this project, you can visit our website www.erroltech.com. You can give us the orders on WhatsApp also. Thank you so much.